so the instructions for this, which I didn't include, would be create a graph with the following limit conditions. And I listed 1, 2, 3, 4, 5, 6 of them in black. And the bottom one in blue is a little new for us. The 6 in black would cover chapters 1 and 2 for the test. The blue one's really a chapter 3 item. So I have this graph, and I've just started by making the x and y axis and labeling the major points that are on it, okay? That said, I think the easiest thing to start with when I have these problems, and I'll try to do it in different colors, is let's put the points on there. You guys agree? Those are easy points. F of 0 is 2. Boom. F of negative 2 is 3. Boom. All right? That means 1 somewhere. All right, so there we go. Now the next thing is at 0, I say the limit, and I'll do this in green. I said the limit at 0 is 4. So if that's 2, 3, 4 is going to be an open circle. All right? And, you know, that's all I got right now. And I got to come in and out of it. So there's going to need to be lines eventually like this. I don't know which way they are yet, so I'll leave them off right now. And maybe since I've handled the 0 and this, maybe I'll handle this limit next. And what's that saying? That just says the limit as x approaches negative 2 of f of x equals f of negative 2, which is equal to 3. We know that, right? But really what this says is that at this point, this is a polynomial function. So maybe I just do this. Have it go through that point and just put an arrow. It doesn't matter which way you go. You just got to go through that red dot as a line. You could go up and down, right? You could go down and up. Those would all be correct. All right? So there we go. We just handled those 4 conditions. So now in black, I'm going to handle this one. The one thing you realize right away at negative 3, or at positive 3, I'm sorry, is that there's a vertical asymptote. And if I go black now, from the left-hand side, it's positive infinity. From the right-hand side, it is negative infinity. And all I have to do is make sure this is a function. So I'll come up to the point. All right? That's all I got to do is make sure it's a function. And now we've handled the 6 limits. And that would be the test. So maybe you make this go away. Now, if I do this, I will tell you that what I just drew is wrong for the last one. Because from 7 on, when x is greater than 7, from here on, what's it say about the derivative? It's greater than 0. What's that mean? That means that the tangent line has to have a positive slope. So look at, what's the slope of my tangent line right there? Negative. So I got to make a little change here if I want my last condition to be true. So I'm just going to get down low before 7 and come back and just do this. And what do we know is about the derivative to the right of 7? Right now it's about positive 1 forever. But it's just greater than 0.
It doesn't have to start getting positive and 7?
Nope. It has to be greater than 7 after 7. So yeah, so do you want to come all the way down and do this?
It started getting positive.
I don't care where the curve is. I just care about, let's be clear, yeah, I can't have 2 lines, okay?
No, I mean like...
Everybody, I can have the slope, as long as it's a positive slope, I can go all the way down. Right? That's a positive slope even though it's located in the negative quadrant. I'm just caring about the slope of, what's that slope? It's positive. It just has to be above horizontal, not below. And that would handle the last one.
Wait, so don't you have to finish the other side of...
The graph?
Yeah, of the 0 is 4. Don't you have to put another on that? Yeah, it's
submit?
Yeah, right there.
Yeah,
The open
the black's
circle.
got to connect to the open one.
The open one.
Oh my gosh, you guys are right. I made a mistake. The black's got to connect to the open one. Otherwise, it's not a limit. No, good catch. It has to go all the way up to the open. Otherwise, it's not a limit.
I thought it already was.
Yeah, I missed it. I was going to the wrong point. Otherwise, it doesn't have a limit there. It would be a jump instead of a removable. A jump discontinuity can't have a limit. Good catch. There you go, everybody. Easy to make mistakes. Keep practicing.